So today I'm going to talk about uh, one one important topic, which is about how technology is going to help produce better data products and the role of parity computing in that, and how Elsevier and Parity together are improving um, data products and the quality through technology. Okay, so one of the key things to derive value from data is entity resolution. So entity resolution is about recognizing names, places, organizations, and chemical entities, and so on. Okay. For example, by resolving references to documents, we can produce citation counts and metrics. By matching affiliations to organizations, we can get organization profiles. By disambiguating authors, we can get author profiles. So therefore, entity resolution is the foundation for deriving additional value. But this is a highly challenging topic, even for standard entities like names and organizations. And the reason is that we have hundreds of millions of documents, and the data is often incomplete or ambiguous. So Parity has, no, here comes Parity. Parity has been working on this entity resolution for almost 20 years since the inception of digital libraries. And we are located in San Diego, and it is led by several PhD level computer scientists with a specialty in artificial intelligence, machine learning, and deep learning. And more importantly, we are steeped in domain knowledge. Several of us publish regularly, and we have association with the university. So we identify with the universities and the users, and we try to craft products. And also we go to the last mile. We're willing to go to the last mile and dedicate ourselves to achieve the quality. So we have done several things in addition to entity resolution, and we have also done tagging technology, which is to tag references and affiliations automatically. I will tell you more about that in a second. And we have also spent a lot of time polishing biomedical entities, which is one of the most challenging things. If you take a patient record, and polishing that is non-trivial. And we also have used these entity resolution techniques to develop many applications. For example, predicting grant winners or best paper winners, or recommendation of job candidates for a particular job, and even literature-based hypothesis discovery. Can you use the literature to come up with new hypotheses for advancing science? So in certain areas, this is very feasible. For example, finding a new genetic variants. Okay. And we have also built clinical decision support systems like the sepsis alert system. Okay. So now we are in one single family. We are acquired by Elsevier in late 2019, and Elsevier provided us with an opportunity to scale our technology and to deal with one of the largest corpus in the world. And so together, we have innovative technology and a strong team to add to Elsevier's strengths. And we have a strategy for further quality enhancements in entity resolution. And we have a number of applications and services planned. So before I talk about some of the new developments in entity resolution, let me take the time to talk about foundational data quality. As you all know, that data or input data quality is essential for getting high quality entity resolution. And Elsevier has made great strides in improving critical field records for foundational records. And if you see these graphs, and in the last couple of years, we have made dramatic improvements, and we are almost at the 99 plus range in terms of quality of fields. So let me take the next couple of minutes to talk about new developments. One of them is automated tagging. And so the idea is that you want to tag references or affiliations before you can match them or resolve them. So you want to identify various components, which is extremely necessary for doing the resolution. And so typically people do human tagging. There are some pluses and minuses for that. But what we have found is that apart from the cost, the human tagging is not only kind of expensive in terms of time, but also inconsistent. We have found techniques using deep learning to come up with automated tagging that is at least as good as humans. And and we have applied this technology for tagging references and affiliations. And to take take 30 seconds, we have used a variety of technologies to improve the quality of organizational profiles recently. The software will be released in the first quarter of next year. And one of the pieces of this technology will be to resolve organizations. So given affiliation strings, we can resolve them to our database. And let me stop here and let me welcome Andre to deal with the second half of the presentation.
Thank you, Mohan. Dear colleagues, I'm Andre Loksev, lead product manager for Scopus author profiles, and in my part, I will cover metrics around author profiles. I will speak a bit about the algorithm we use to disambiguate author profiles and about our recent improvements and next steps. So first, I want to emphasize that we fully understand how important are author profiles as building blocks to evaluate research, to make decisions with a high value. And therefore, our primarily focus with author profiles is highest accuracy. So we focus on, first of all, precision, that the author profiles don't include any long articles written by different people, the ones which are not the profile we create. The next step is we're looking at minimizing the split so that for every researcher, we ideally have only one profile. And the third priority is enhancing author profiles with additional data. So this is the new view of author profiles. Maybe you have seen that in Scopus, we have updated the author profile page, and it shows that actually we're speaking not only about the list of publications per se, but about all the output metrics which are based on this list. We fully understand that the list is needed to calculate number of citations, age index, and various other metrics. And here we have an example of prolific author where the main challenge is to have all the publications of this author in one place. But more commonly, we face the other challenges where, as in this example, we have 4 different authors with a completely same name from the same country in the same subject area, each of them written 1 or 2 articles, and we have to disambiguate them correctly. So how do we measure the accuracy of author profiles? So we actually look at 2 main metrics. So this is the precision. So we check if the profile of each publication written by someone else, and the completeness, meaning the profile includes all publications by the author. And for precision, 98.3% of profiles are fully precise, and 90.6% of profiles are 100% complete. With these numbers, Scopus compared to peers have the highest completeness and precision. We work with a full data set of Scopus, 80 million publications, but more importantly, 270 million author sequences, where half of them have only initials. Many of them have the same name, like we have almost 400,000 author sequences of Y-rank we have to disambiguate, so quite a challenging thing. So how do we approach this? We combine automated algorithmic approach, which is developed by Parity, and also we combine it with user feedback received from Author Feedback Wizard, from ORCID, Pure, and various other services. And actually, the algorithm respects the feedback we receive from the users in the way that if the user decided that several articles should be kept together or kept apart, and we have checked that this decision is legitimate, then it's cannot be overridden by algorithmic approach. But what actually the algorithmic approach does? So it takes all the author sequences and gets all available evidence for them. And this is not only obvious fields such as names, emails, sources, numbers, but also subject areas and keywords and list of co-authors and many various fields to correctly disambiguate these author sequences. And then we do a cycle of pairwise comparison of all author sequences having the same surname and initials, and based on a elaborated set of rules, whether we will merge or not merge these author sequences, and we apply this cycle for several times until we receive the best view of author profiles. And on my last slide, I want to speak about the recent improvements. So we see how fast is the author profile corpus growing. Therefore, we created a new scaling infrastructure to faster profile the authors. We have recently completed profiling of preprints. You will soon see in a separate tab on Scopus author profiles. And of course, we look further to continuously improve and tune the algorithm for profiling to incorporate more external sources of data for better disambiguation. And also for the new types of data, such as preprints or awarded grants, which you have in Pure, we are creating now a curation channel so that the users will have the functionality of providing the feedback in the same manner they can provide the feedback via author feedback wizards for core publications in Scopus. Thank you for your attention. With that, I conclude my presentation.
Right. Thank you, Andre. Thank you, Dr. Mohan. So we have time for maybe just a couple of questions. One that came through is, what data points and or data sources could possibly be incorporated to improve the reliability and precision?
Let me speak about organizations. For organizations, we want clean affiliations. So people stating their university name and the department name together with the city and country will be extremely helpful to create excellent organization profiles. For references, following the editor's best practices to cite references, that will produce excellent reference resolution. So Andrea, you want to talk about authors?
And for author profiles, I would add the full name, email, and sources, ideally not only for the corresponding author, but for all authors in their publication.
Great, thank you. And on that point, perhaps a question from me is, what is your biggest challenge attaining 100% with regards to data quality? What's the biggest hurdle that you are facing?
So the biggest challenge is the long tail. So we do get very high accuracy for almost all of them, but the tail in terms of organizations, for example, really is in millions. And they all have a few publications each. Getting all of them right, given that organizations change the names quite often. I'm talking about smaller organizations. So that becomes a hugely challenging task.
Thank you. Maybe just one last question before we end the session. Is ORCID included in the list of parameters for output selection to a profile?
Yes, it is included. We use ORCID data to disambiguate the researchers, but we cannot fully trust it, meaning that if, let's say, we see that the ORCID is the same, we should automatically merge the profile. So this is an important factor, but we also have noticed that in ORCID database, there are unfortunately a lot of errors, so that's same people have the same person can have different ORCIDs or vice versa. Several people are having the same ORCID, so we use it as a part of evidence, but together with other parameters.
Thank you. We are on time, though we have a couple more questions, so I would encourage the questions to be kept, and we can probably address the person who asked it later. So thank you, Dr. Mohan and Andre, for your time and your presentation.